Okay, and like most of the reactions we've got, or most of the tests, we're gonna have naming, structures, um, structures to name. And we're gonna have reactions and intermolecular forces. So let's start with these guys. Let's start naming these. Okay, so that's an aldehyde. And that'll be the backbone. So it's a 1, 2, 3, 4, 5. One, two, three, ethyl. Now you can put the one there if you want. Most textbooks leave it off, but it is optional if you want to put it there just to be consistent. Okay. This is a cyclic, five-membered cyclic ketone. With a ethyl group at 1, 2, 3. By the way, this worksheet, let me verify it's in Canvas. Yeah, it's this one here, very top one. Okay, so we've got another ketone. And remember, the backbone has to include the functional group, no exceptions. You could say alkanes is kind of an exception because it doesn't really have a functional group. Other than alkanes, though, everything else, functional group has to be included in the backbone. Okay, 1, 2, 3, 1, 2. Now I have two options on naming, numbering this from the left to the right. The ketone, the carbonyl group is carbon number 3 either way. But if we start from the right going left, the methyl group will have a lower number. So that's the way we're going to do it. Starting here with 1. Another pentanone. Why is the food out? Anyone know? Is it for anyone? And we have all these pentas. Okay, so this is going to be a, now you could make a case that this is a trans. And this is going to be the same thing, only cis. Now this is a phenol, which includes this guy here. So that automatically becomes carbon number 1. Can we ever have a cyclopentanal? Correct. Why?
Kind of this, like, we can have a cyclic aldehyde.
Yeah, we can never have an aldehyde in a cyclic unless it's a branch, but it cannot be on off the ring because there are no hydrogens there. The aldehyde has to have a hydrogen in that carbonyl group. So the only thing you can have is a ketone. Well, this name is screwed up. Same with this one. 3 should not be there. Because it automatically is carbon number 1. Okay, then isobutyl. Okay, so we have pentanone. This time is a non-cyclic one. Now this could be cis or trans. Yeah, I've written it as a trans, but it could be, you could also do it as a cis. Cis would look like this. Okay. Are there any questions about any of these? All right, let's talk reactions now. Why don't we make a ketone? Well, make a ketone, we have to oxidize an alcohol. You can also reduce an acid. Talk about that in unit 3. So what alcohol do we need? We need a secondary alcohol with the backbone. This is a it's a six-membered backbone. Okay, and we're going to oxidize that. So this is going to be a 2-hexanol 3-methyl. And this would be a 3-methyl. All right, that didn't count very well. Okay, we have an aldehyde with nothing happening to it. What if we oxidize it? Okay, here we have a secondary alcohol oxidized to a ketone. Here we have secondary alcohols, acidic conditions, 2 temperatures. So at the higher temperature, it's going to create an alkene, and we're going to get a mixture. Because we're looking for a hydrogen. This way and this way. So which of these is more stable? Okay, Markovnikov is going to give us the same result, but the one on the right is a little more symmetric. So it's going to be that one. Oh, I forgot to name this guy up here. This is a Same here. These are all 2-methyl. Okay, so this is going to be a and this one's going to form an ether at lower temperature. That means where the alcohols are is where they're going to be joined. So this is going to be a dye. Oops. Okay, here we have phenol in an acidic environment, so nothing happens. Only in a basic or alkaline environment will that hydrogen be pulled off. In an acidic environment, nothing happens. So this is a phenol. And it's a okay, so here we have some acetals and ketals. How do we make them? Okay, so an acetal, ketal, or hemi versions have a secondary backbone and a primary backbone. So if we look at the primary backbone, that's where the anomeric carbon resides. Okay, and here's where the anomeric carbon is, right here. And so this is a hemiacetal. So we make it with start with a aldehyde. That's our primary backbone. This is our secondary. So the secondary starts with a methanol, 1 carbon long. So we need a 1, 2, 3, 4 carbon aldehyde. So this would be a methyl. Okay, let's look at the next one now. Okay, we have OCO again. And we have, there's a hydrogen here on the anomeric carbon and no OH. So this is a acetylene. Okay, the primary backbone is 1, 2, 3, 4 again. And the secondary backbones are ethanols, 2 carbons. So we can do this in 1 step or 2 steps. If we do it in 1 step, we're just going to say we need 2 of those ethanols. And then another 4 carbon aldehyde. So this is going to be ethanol. Okay, OCO again. We have no H's or OH's, so this is a ketal. Primary backbone is this guy. This is going to be a 2 butanone plus 2 methanols. Okay, so we have a cycloketone. Ketones cannot be oxidized, so this is a no reaction. Okay, so we've got a ketone and an alcohol. So that can form a hemiketal. And since there's no 2 here, it's going to stop at the hemi rather than going all the way to the ketal. So this is a propanone ethanol. Now, if we had two ethanols, it would go on to the full-blown ketal. We just added here, for example. So we've got OCO, OH, no OH. So this is tel. So this is up here, that reaction. Okay, how can I make this isopropanol? Two ways. Okay, we can start with an alkene, or we can reduce a ketone. So let's start with a ketone. So this is exactly the same reaction. I don't know why I duplicated it. Start with ketone, an aldehyde, reduce it. Since it's a primary alcohol, you need to start with an aldehyde. Okay, here we've got the Benedict's reaction, it was a copper. The next one down is with silver, so that's the Tollens reaction. And here we have Benedict's again. Okay, so Benedict's solution is sensitive to aldehydes, not ketones. So this one down here is we're starting with a ketone, so there's going to be no reaction here. Cannot oxidize the ketone. You can, however, oxidize an aldehyde to the acid. So we've got a 3-carbon aldehyde, so we're going to end up with a 3-carbon acid. And it's in an alkaline environment, so it's the acid salt. And we're going to reduce the copper to a +1. So, and you just need to name this acid salt. So this is being oxidized. This is being reduced. This is the same reaction only with silver rather than copper. Okay, this is a 3-carbon, so this is a propanol. Okay, here we have an aldehyde being oxidized. Okay, here we have glucose and the tolerance test with silver. So first step is the glucose has to open up. The aldehyde. And that aldehyde now is susceptible to oxidation. To the acid salt. Here we have maltose in a Benedict's test. So it has to have a hemiacetal present to open up, and we do. On the right side, the right glucose, the left one is in a full acetal, which cannot open up. So first step is we draw it, and then we draw it opened. So that aldehyde there is going to be oxidized. I know what we're doing last Wednesday. And that's probably the trickiest reaction in this unit, is the one we just did. Okay, so we have a secondary alcohol. It's going to be oxidized to a ketone. So this is 2-propanol. And this is 2-propanone. And the 2 is optional. Is that, for that to be a ketone, that's the only eligible place it can be. So here we have a aldehyde being reduced in a hydrogen environment. So this is going to be butanal. It's going to go to butanol. Okay, here's the same reaction that we did up here. Need to oxidize a secondary alcohol to get a ketone. I'm not going to name it because we've already done it. Okay, here is a aldehyde, so we need to oxidize a primary alcohol. Now let's do it. Here I have a ketone undergoing oxidation, which won't happen. Okay, and here we have an acid. And the backbone is 1, 2, 3. So that's propionic acid. You don't have to name it till next unit, though. All right, so we need a 1, 2, 3 carbon backbone. Okay, and here's carbs that we went over last week. Here are the answers. Okay. So that's a good worksheet for you going through for studying for the test. As well as the one we went over on Wednesday. Now on Wednesday, I'm gonna have another short lecture because the SOAP lab. And we're gonna just kind of keep going over these. But yeah,
The last video you labeled it butanol, wouldn't it be pentanol?
which one?
The very last one, even. Down all the way at the end. So it's maybe going to find the. Sorry, not pentanol, propanol.
Propanol, yes. That's Al, for the aldehyde. So. Some instructors get upset when they're corrected by students. I was just, oh yes, I'm still human. So that's what I wanted to do today. Just review. And we'll do the same thing on Wednesday. I'll come up with yet another worksheet. Okay, then we have a break this week. And then we'll have a test when we get back. Now already practice this on that Mondays that, yeah.
Oh, yeah, I was just gonna ask, the unit two, because of the touch related, there's a bunch of practice tests. Which one is the most applicable?
The latest one.
The 2019.
Hmm?
The 2019 one. I guess this was. I saw one on this from last year, 20. It's a very unit two, this.
Look at let's look at line drawings. If it says Chem 131, that's from Washington, that's at least 5 years or 6 years old. But don't look though. Look at the ones with line drawing, and there's a date, is that one. Okay, that's what I'm going to cover today. Start lab early. Assuming the other class is out. Okay. Hmm?
They get out like.
That's what I mean, we're pushing 12, so. I'm not gonna be done here before then anyway, so I'm gonna take all this stuff down. Because I'm still talking and recording.